Takin, a trip through space, is one of the weirdest decisions anyone could think of. Talk more of traveling in the starship that uses 33 Raptor engines and burns highly inflammable fluids to propel itself. And another threatening situation that poses a high risk to life is traveling to a far planet like Mars, which has tiny oxygen that is not enough to sustain human life. If you want to dig deep, you could think Elon Musk is crazy by believing a journey to Mars is feasible, and maybe he cannot finish what he started, but the buzzy challenge is that the billionaire entrepreneur is determined to land on Mars. Even though there is a high risk of life involved in transporting the starship through space, the sweet truth is that the return on investment is always juicy. That is why Elon Musk do not consider failure. Instead, he puts his mind in a winning state, and imagine a simple fact that if he succeeds, there will be a roller coaster of massive ROI from every angle into his pocket, and he will be raised to another apex of wealth every day by day. But the most underrated question is, how did SpaceX finally discover how to prevent this 33 Raptor engines on the booster from exploding while journeying from Earth until it detaches itself? And how did the company plan to make these 33 Raptor engines escape explosion? Let's find out in today's video. Even though the return on investment is undeniably substantial, with the potential risk involved in understanding the universe, improving on viable means to be mobile between other planet and Earth brings us to the reason why the company always toil hard to innovate and create approaches to space flights, as well as developing many groundbreaking solutions to some of the biggest challenges in the industry. One of the most recent genius solutions is to save 33 super heavy booster engines is to first understand how SpaceX will work out the use of all the Starship's engines. As we all have the idea that SpaceX will use 33 Raptor engines to power the super heavy first stage and 6 on the Starship upper stages, so if the forthcoming test flight didn't go as expected and the Starship ends in a tremendous crash, SpaceX will potentially lose 39 Raptor engines. This number of engines is so many to lose at this time, not even when the company has made so much investment that has not yet birthed a massive return. Hence, of course, there will be a potential loss in production cost and time. But will Elon Musk allow this massive failure on the first try? The answer is a resounding no. However, don't worry, SpaceX is not yet short of ideas on the right part to take to save the Starship from crashing, and that is why the launch tower will play a significant role in enhancing safely, reduce launch cost, and aid reusability. It is expected that the Starship's launch tower will catch the Super Heavy in midair before it lands. Though that is an insane idea, considering a factor of hard landing on the catching arms, and that again begs another question, such as, how will SpaceX control the speed of the booster rocket as it gradually submerges between the two chopsticks arms without hitting hard on the surface and destroying the whole chopstick structure? Well, the direct and most accurate answer for this is the use of sensors and actuators in machine parts. In engineering, there are many types of sensors, detectors, and transducers that are used for detecting a physical presence such as flame, metals, leaks, levels, or gas and chemicals, among others. Some are designed to sense physical conditions such as temperature, pressure, while others can detect motion or proximity. In the case of the Super Heavy landing on the chopsticks frame, SpaceX will consider using the proximity and motion sensors to detect the proximity between the chopstick arms and the booster grid fins. Also, the motion sensor will control the movement of the two chopsticks arms for an accurate movement during installation of the booster on the launch mount. There is also a system of horizontal rollers on the catching arms so that the booster will not crush on the catching arms and cause explosion, yet let the catch arms slide along the booster sides and have a solid grip to the grid fins. All this will be done within a few minutes, so precision of the whole process is very paramount. So to keep the process accurate, it's all about giving the timely precision of aiming the booster between the arms. That means tolerance zones of the proximity sensor will be measured in meters to avoid hard landing. But wait a second, since we all know that the Starship will exhaust its fuel while journeying to space, inevitably, there needs to be a hanging spaceport built in space to refuel the Starship and give it maintenance test. That is why having a spaceport up there is mandatory. After testing the Starship severally and everything looks good, SpaceX may be contemplating on building a hanging company in space. Something in Earth orbit where these rockets can have their base and be technically examined? This would certainly lower the mechanical stress of Earth landings. Sooner or later, we'll be mining asteroids and moons for the raw materials, so smelting, rolling, and stamping factories will become necessary to be built in orbit. And if you want to know how that will happen, you have to know that it's not in your place to think. Rather, spaceflight engineers may wake up one day and amaze us with the possibility of this reality. However, with time, we will be having several space industries hanging up there in orbit, and that will be another groundbreaking modern-day sci-fi engineering of our time. Another most interesting question you should ask is, how will Starship cope with the heat from 33 Raptor engines? It's quite pretty much the same way as every other rocket ever launched, by relying on the simple fact that nearly all the heat generated by the combustion of fuel and oxidizer is being used to expand the gases generated in the combustion chamber. A great cooling circuit will definitely be installed with the engine to ensure that the combustion chamber and engine bells don't melt. That is, there will be a freezing fluid running through the body of each of the Raptor engines, and this is addressed by the fact that they run on cryogenic fluids that flow at very chilling temperature of -175 degrees centigrade. If you look at the sketch diagram of a naked Raptor engine, you will see that cryogenic methane fuel is used as a coolant for the hot sections of the engine, and the temperature received will be of benefit throughout the whole combustion process. The Starship makes use of autogenous tank pressurization, which means that the fuel and oxidizer are vaporized by the engine pumps and in their gaseous state, used to keep the tank pressures within a narrow range required by the turbo pumps to maintain a controlled temptation for the working process, and this will continue so long as the engine keeps burning without any glitches. The energy needed for the perfect working condition is the waste heat from the engine. So, the Raptors will maintain their feed tanks at the correct pressure and cool themselves slightly at the same time. On the other hand, if you may feel that the heat radiates sideways from one engine to the other and which may fracture the super heavy thrust structure, then it's less of a problem for Starship Booster than most other first stages because the Raptor engine bell seems to be cooled all the way down to the exit. SpaceX is good at running engines in close proximity without having any glitch because they have found a way to work with regeneration cooling techniques that save the engine components from melting. And this scenario is quite opposite to the Merlin vacuum engines that cool the bell radiatively. For example, the Sea-Level Merlins and Falcon 9, radiative cooling is employed. The company also experienced, from Starship 10 km flights, of running 3 Raptors in close proximity, and seemed confident testing the Super Heavy booster using 28, 29, or 33 Raptor engines all at the same time. Hence you might see the Raptor engine that is firing at high temperature, ejecting green flames and thinking the heat will melt everything down there. But now you could reason again and confirm you are all wrong. You may be seeing the Raptor engine burning extremely down there, but on the inside, there is a great cooling effect taking place. Do you have any insight to contribute to SpaceX about the cooling process of the Raptor engine?